Well, let's continue. Last time I have told that I have basically created this table, and I told you that marginal revenue of a second unit is less than the price, the revenue it brings, because basically um, the average revenue, I mean the money you got when you sell the second unit, and that's because to sell the second unit, you need to also reduce the price of the first unit. And when we are talking on the marginal revenue, I mean, don't think it like, I mean, I sell first the first unit and then sell the second unit. It's rather than I am thinking about selling just one unit or selling just two units. That's why while thinking that, I also think how much additional revenue I will get when I sell two units instead of one. Uh, so, and margin revenue is always less than average revenue, and at the quantity 6 it is 0. It is 0 because I mean, when you, for example, get the uh, third unit, now you by selling this third unit you got $80, but you lose 10 additional dollar from both first unit and the second unit. So you got 80, you lose 20. And at the sixth unit, you got $50, but you lose $50 in $10 per unit you have previously. I mean, for the previous 5 units, 10 you lose $10 per unit, which means you also lose $50. So your margin revenue reduced to 0. Now, what happens in the labor side? On the labor side, we also have a monopsony, but we need to define certain things first. Um, well, every worker, as we have read this. Okay. So, initially, when you, okay. When our workshop hires one worker, the wage is $20. Hiring one more worker will increase the wage by $10. So the more worker you hire, the higher will be your basically wage. And uh, we assume that the margin productivity of the workers is the same. Actually, if margin productivity of workers are less, in that case, I mean, in order to produce, for example, two shoes, you might need to, for example, if margin productivity of workers fall to the half when you increase the number of shoes produced from 5 to 6, because now you need to hire an additional worker. Now, of course, the cost will increase even more because now you need to pay more to the worker due to wage increase, but also the worker produces less. So the diminishing marginal productivity is actually increasing the labor costs even more, basically. But even if marginal productivity of the workers is constant, our labor cost will increase because the wage rate is increasing. So here we ignore the basic assumption of diminishing marginal utility, even though it's easy to include that also to the analysis, although it makes it a little bit more complex, and without it we can show the main point of the analysis. And I challenge you to add that actually. If you want, you can add the diminishing marginal utility also. But this makes one basic, this helps us in one sense. For each quantity of worker shoe, we need only one additional worker. So otherwise, for example, for the first worker, you might need 5 workers. For the second shoe, you might need 3 workers if margin productivity initially increase. For the third, maybe 1 worker. For the fourth, again, 3 workers. For the fifth, maybe again 5 workers. So basically, instead of wage, when you basically calculate labor costs, you need to look to you need to calculate wage times the number of workers you hire when you calculate the um, basically labor cost per unit for every unit of shoe you produce. Um, and of course, in that case, I mean exactly finding marginal cost. Well, you can find marginal cost of shoe in that case. Of course, things will become more complex because now also the wage of the workers are increasing. Uh, so things will become more complex basically when you have that case. You can still produce that case, and if you are curious, try it, and we can also discuss it basically. Um, but sticking to the simple case, and the simple case will be interesting enough. We start with $10 wage, I believe, $20 wage, which will be our average cost at the same time. And the cost will increase by, this is average cost at the same time. And it will increase by $10. When you increase number of shoe you produce by 1 unit, also number of workers you have by 1 unit, not 1 but 10 here. So total cost is similarly, you need to multiply the wage with the quantity. Other costs except the labor costs are negligible. Marginal cost for the first one, it is this. For the second one, you need to subtract this from this, because I mean you basically calculate the cost of producing the second unit, which is the wage you pay. The additional cost created by basically producing second unit. Note that marginal cost is higher than the average cost or wage. Why is this so? Again, note that it is not like we hire the first worker, pay him $20, and we hire the second worker and pay him $30. It's rather that in the very beginning we decide how many workers we are going to hire. And if that's the case, well, if we want to hire 2 workers and we need to pay the same wage to both, to attract the second worker, we need to increase the wage to $30. So we also need to pay the first worker $30. So our cost is $30, which we pay to the second worker, plus the $10 we pay to the first worker, which we didn't need to pay if we were just hiring 1 worker. For example, when we increase number of workers from 5 to 6, marginal cost of our 6th worker is 120. And why is this so? This is so because when we hire 6th worker, we pay $70 to the 6th worker and additional $10 for previous 5 workers we have hired, which is $50. So the marginal cost is 70 plus 50, which is 120. So what will be the production level in this case? Our company will produce as long as the revenue of producing an additional unit is higher than cost of that unit. Well, when you produce 1 unit, when you produce nothing and decide to produce 1 unit, the revenue the first unit will bring is 100, the cost is 20, so you will produce the first unit. Basically, when you produce the second unit, the revenue it brings is 80, the cost it will bring is 40. When you produce the third unit, again, note that each unit represents also 1 worker, which means hiring 1 worker, 2 workers, 3 workers. The revenue it will bring is 60, the cost is 60. You are indifferent, you might do it or you might not do it. When you produce 4 units, in that case the marginal cost is 80, marginal revenue is 40. So you won't produce 4 units, you will just produce 3 units. So 3 units is the optimum production points in this case. Interesting. Up to now, maybe there is nothing that much interesting. Well, you might draw the lines of the basically average revenue, marginal revenue, average cost, and marginal cost. I think you should know it. You basically use this chart. So I'm just showing you how the drawings will look like. They will look like this. So this basically line represents the marginal revenue. This line represents, I'm sorry, moment. This line represents the demand, basically, average revenue per unit of shoe you sell. This line represents marginal revenue per shoe you sell, which is decreasing because the price is decreasing as you sell more shoes. This line represents the average. This line represents the marginal cost, the average cost, basically, of producing one shoe, which is equal to the wage of worker you pay to produce that shoe. And this line represents the marginal cost of producing that shoe. So the production will be at the level where marginal cost and marginal revenue intersects, which is this point, basically. Okay, let me tell you right away an interesting case of this point. So this is a case when you have a company which is monopoly in the product market and monopsony in the labor market. But the basic results will be same if you have a company which is operating in a perfectly competitive market in the product market, but monopsony in the labor market. The result will still the same, and you can test it. Well, what is the wage the worker is getting in this case? Wage the worker is getting in this case represents by the average cost, which is $40. Right? Yes, it is on this line. What is the revenue this worker is bringing? This worker is bringing a revenue which is equal to, well, basically, you might say you might look to the marginal revenue curve, or you might look to the average revenue curve. Both are actually understandable, but you might look to the marginal revenue curve by assuming, I mean, if you hire this additional worker, in that case, this additional worker will produce one more shoe, and producing this additional one more shoe will bring me $60 additional revenue. The revenue the worker brings is $60. The cost of the worker is $40. The wage you pay to the worker is $40. So the marginal revenue the worker creates is higher than the wage you pay to that worker. In that case, even in the neoclassical sense, you have exploitation. You have exploitation of the worker. So, in case of monopsony, at the optimum production level, logical point at which the company will produce at, the workers will be exploited. According to our model, the basic model, we are not doing anything else except the traditional marginal analysis, basically here. Okay, so these curves are basically taken, but basically what happens is the demand is taken out, since we are focusing on the labor market. I mean, it's not necessary to show the demand. The critical curve is here, the marginal revenue of product from the product side of the market. But we keep the marginal labor cost and the supply curve. Supply curve is the labor supply, which shows you at which wage level how many workers you can attract. So we will continue using this graph in the next part. See you in the next part.